Hello everyone, good evening to all of you. Today I am going to discuss about the numericals of our NCERT solution of the class 12 physics, and our topic will be current and electricity. So let's go to discuss one by one. Question number one. So our question number one, that is itself, let us read this question. A storage battery of a car has an EMF of 12 volt, and if the internal resistance to the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? So let's write first of all what they have provided you. They have provided you EMF of the battery as 12 volt, and internal resistance that we will denote it by small r, that is equal to 0.4 ohm. And what is the maximum current? So I maximum will be how much? So we know that maximum current will be drawn when there is no external resistance, or external resistance is zero. So we are not considering external resistance. Basically, if external resistance will be there, so what type of formula we have to use? That is equal to E by capital R plus small r. But the thing is that we are considering our external resistance is zero. So finally, maximum current, for maximum current, external resistance should be 0, and this is equal to 12 divided by 0.4. So this will be 30 ampere. So I hope you have understood this question. Okay. Now let's go for question number 2. Okay. Question number 2. It is saying that a battery of EMF 10 volt and internal resistance is 3 ohm is connected to a resistor. If the current in the circuit is 0.5 volt, what is the resistance of the resistor? What is the terminal voltage of the battery? Now the thing is that we need to draw the circuit first of all. So let us draw this circuit. So this is a battery and it has internal resistance. So I am closing it so that you can understand this is an internal resistance, and now it has been connected with the external resistance, and that can be denoted by capital R. Now in EMF is that without internal resistance if you connect so that is EMF. And when we talk about the terminal voltage, so this is A and this is B, so our terminal voltage will be VAB, like this, right? Got it. Now let's solve it. So what they have provided you EMF. So it means that EMF is they have provided you 10 volt, right? They are asking you terminal voltage, right? Internal resistance they have provided 3 ohm and is connected to the external resistance, and we don't know the value of external resistance. We don't know that. We need to find that also. We need to find that, and it has a current of 0.5 ampere, right? So I basically what will happen if you try to solve this one? So basically it will be I is equal to V by R, that is when terminal voltage is given. But we will not use this formula here. What type of formula we will use? This is equal to EMF divided by total resistance, and this is equal to 10 volt divided by total resistance, means external resistance plus internal resistance, and this is equal to small r. So again put the value. So this is 10 volt and external resistance is R plus internal resistance is 3, and this whole is equal to the current which is given as 0.5. So just do it. So this will be R plus 3 will be how much? 100 by 5, that is 20. So R will be 17 ohm. So we have got an external resistance. Hence external resistance we have 17 ohm, right? Now what they are asking now, terminal voltage. So terminal voltage basically is equal to EMF minus is current into voltage drop, that is 10 volt minus current is 0.5 into internal resistance is 3. So this will be 10 minus 1.5. So we will get terminal voltage as 8.5 volt. So this is our terminal voltage. So I hope you have understood this one. So I hope this is you have understood. Now let's go for next question. Our next question is, at room temperature 27 degrees Celsius, the resistance of a heating element is how much? 100 ohm. And the temperature of the element if the resistance is found to be 117 ohm. Alpha, the temperature coefficient they have provided you. Now the thing is that you need to write in a proper way. Let us suppose resistance is R1 is equal to 100 ohm when temperature T1 is equal to 27 degrees Celsius. So let's erase that so that it will be visible to you. So this is 27 degrees Celsius. Okay. Now they are asking what will be the final resistance is equal to how much if temperature will be, no sorry, they are asking that the resistance itself is 107 ohm. So what will be the temperature at this point? They have also provided you alpha is equal to, that is coefficient of thermal temperature coefficient of the material, that is equal to 1.7 into 10 to the power minus 4. Now the thing is that we know that R2 is equal to R1 1 plus alpha T2 minus T1, right? So let's put here the values. Our R2 is 117 and R1 is equal to 100, and this is equal to 1 plus alpha is equal to 1.7 into T2. T2 that is equal to, we don't know, minus T1 that is equal to 27 degrees Celsius, right? Now if we do this, so it will be 117 divided by 100 minus 1. Yeah, yeah. That's is equal to 1.7 into T2 minus 27 degrees Celsius. Now one more mistake what I have done, this is equal to uh, mm, so the mistake which I have done here is by putting the value. So let us put it in a proper way. It's a 1.67 into 10 to the power minus 4 into temperature T2 minus T1 that is equal to 27 degrees Celsius. So this is equal to 1.7 into 10 to the power minus 4. And this is equal to T2 minus 27 degrees Celsius. So from here what we can infer, this is equal to 17 divided by 100. This is equal to 1.7 into 10 to the power minus 4, and this is equal to T2 minus 27 degrees Celsius. So from here what we can get, let's calculate it. So this will be T2 minus 27 is equal to, just put it, so it will get 117 divided by 100 into 1.7 into 10 to the power minus 4. So that's is equal to, it will go up 10 ja 5 minus 3. So this will be probably 1000, and this is equal to T2 minus 27. Now the final temperature from is this will be how much? Final temperature will be 1027 degrees Celsius. So I hope you have understood this one. So let's go for next question. Now let's read this question. A negligible small current, a negligible small current is passed through a wire of a length 15 meter and a uniform cross section of this one, and it has a resistance of 5 ampere. What is the resistivity? So I hope it's the easiest one question. So let's do. So length is equal to 15 meter, cross section, uniform cross section, and uniform cross sectional area is 6.0 into 10 to the power minus 7 meter square, and resistance is 5 ohm. Rho is equal to how much? Yes. So we need to find a resistivity, right? So how to find resistivity? R is equal to rho L by A. So from here we need to put the values. So rho will be how much? Rho is equal to R A by L. So R is how much? 5 into area is 6 into 10 to the power minus 7 divided by length is how much? 15. So this is 3, 3, 2 ja 6. So finally resistivity is equal to 2 into 10 to the power minus 7 ohm meter, right? So this is the final answer for this question. I hope you all have understood this one. So let's go for next question. Now this is question number 3.5. A silver wire having a resistance of 2.1 ohm at a 27.5 degrees Celsius and the resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of the resistivity of the silver. What they have provided you? They have provided you R1, that is equal to 2.1 ohm, and temperature T1 is equal to 27.5 degrees Celsius. Again they have provided you R2, that is equal to 2.7 ohm, and temperature T2 is equal to 100 degrees Celsius, right? They are asking alpha. So alpha is equal to what? Alpha is equal to T2 minus T1. Sorry, alpha. If you put the value, so it is R 1 plus no. If you want to use the direct formula, so you can use this formula. Just I'm writing you writing. So this is alpha is equal to R2 minus R1 divided by R1 into T2 minus T1. Now put the value so that we can get the alpha values. So R2 is how much? R2 is 27. R1 is how much? 2.1. 2.7 and 2.1 divided by R1. So R1 is how much? R1 is 2.1, and temperature difference is how much? It's 100 minus 27.5. Got it? So basically when you calculate it, so just try to pause the video and try to calculate it by your own. So when you calculate it, so finally you will get the values which is equal to 3.9 into 10 to the power minus 3. 3.9 into 10 to the power minus 3 per degree Celsius. So this is the final answer. So I hope you have understood this one. So let's do this question. The question itself says that a heating element using a nichrome connects to a voltage of 230 volt supply, draws an initial current of how much? 3.2 ampere. So what they have given you, let's write step by step. There is a heating element, right? Heating element using nichrome connected to a 230 volt power. So voltage is 230, right? And the current fetching by this is how much? Current fetching by this is 3.2, right? At a temperature, so at the same time temperature they have given you how much? Temperature they have given uh, temperature they have given you, here you can see that what they have provided you. V is equal to 230 volt, current is equal to 3.2 ampere, and the current and temperature is around, for this one, temperature, what is the steady temperature of the element if the room temperature. So for this case temperature they have provided you how much? 27 degrees Celsius. Now the scenario is that, scenario is that voltage will be same 230, got it? Current will be different, right? Current will change to 2.8, got it? So what will be the new resistance? So definitely here, let us suppose first of all you need to find the resistance, that is R1 is equal to V by I. So from this condition, so we will get 230 by 3.2. So from here we can get 71.87, right? And by using this also we can find R2 as equal to 230 divided by 2.8. So basically it will have 82.14. So as soon as C heated, so what will happen, temperature, see what will happen, resistance will increase. Now earlier the room temperature was, that is 2 T1 is equal to 27 degrees Celsius. The final room temperature is how much, we don't need to know, but they have also given you the data that alpha is equal to 1.7 into 10 to the power minus 4, right? 10 to the power minus 4, right? Understood? I hope you have understood this one. Now how to solve this one? We need to check it out. See, we know that temperature T2 minus T1 is equal to, the basic formula you need to know, that is R2 minus R1 divided by R1 into alpha. So put the values. So T2 minus T1. So T2 is how much? T2 we don't know. We need to find temperature minus 27 degree is equal to R2 is how much? R2 is 82.14. 82.14 minus R1 is 71.87 divided by R1 is equal to 71.87 into, this will be how much? It will be approximately 1.7 into 10 to the power minus 11, right? So by using this we will get the temperature is approximately equal to 840.5. This is equal to T2 minus 27 degrees Celsius. From here we can find T2 is equal to 840.5 plus 27. So from here we can get 867.5 degrees Celsius. This is the final temperature, right? So I hope you have understood this question 3.6. So till 3.6 we have done. Okay. Let's go for next question. The next question itself shows me that yeah, Determine the current in each of the branch as shown in a figure, right? Now let us consider this current is I1. This will be how much? I2. Got it? And this current will be how much? So let's suppose this current is I3. So this will be. So one more trick we can use so that we can do some shortcut. So let's go and create a shortcut solution for this one. So in this section, I1 is going inside, right? Plus I2 is going like this, right? And its current should also come like I1 plus I2. So we have this branch, we can say that current will be uh,
determine the current in each branch of the network shown. इस नेटवर्क में गौर से देखो, ये बैलेंस इसमें बैलेंस मतलब जा रही है आई, यहाँ से करंट ये आई वन जा रही है, इसकी जा रही है आई टू, तो रिमेनिंग करंट यहाँ पे इसमें कितनी आएगी? आई वन माइनस आई टू, आई वन माइनस आई टू, ये करो आई वन माइनस आई टू, यहाँ से आएगी, यहाँ से आई टू आएगी, दोनों मिलकर आई वन आएगी, और वापस से कितनी करंट आ जाएगी? एक इक्वेशन तो ये बनेगी, आई इक्वल टू कितना है? आई वन प्लस आई टू।
now let's do it. So let's analyze the circuit. So from here, what we have, let's suppose this is a current I. So I will go inside and I will come from this one. So can we see that I can be split like this I1, and this will, there will be an I2, right? Now the thing is that current is being split like I1 plus I2. So current will come to combine, and we will get the same amount of current, that is it should be I2 and it should be I1, then only we will get like this. So definitely if I2 is the current which is going from this side, so from this branch we will get I1 minus I2, right? So we have got this. So why can't we write here I as a I1 plus I2, and here also I can be written as I1 plus I2. Now we will use the circuit to solve this one. So we have how many unknowns? We have two unknowns, right? So we will do this one, two unknowns. So first equation we should take a first equation from this one. So in terminal AB, in terminal A, B, C they have not provided you, so let's make here D, right? So it will be how much? It will be A, B, C, D. A, B, D only, not C, A, B, D. It will be A, B, D only, right? So here we can say that in terminal A, B, D, A, B, D, let's solve it. So this will be how much? So this will be 10I1 plus 5I1 minus I2 minus 5I2 is equal to 0. And again we need to take this terminal, so other terminal will be, we can take this terminal as a closed loop. So what we can say, uh, in terminal A, D, C, A, we can say that 5I2 plus 10I1 minus 10 plus 10I1 plus I2, this is equal to 0. Now put the values of here from I1 and I2. So let's solve it. So this is 5I1 plus 10I1. So this will be 15I1 minus 5I2 plus minus 5I2 minus 10I2, that is equal to 0. So from here 3I1 minus 2I2 is equal to 0. So from here we can put the values of I2. So I2 will be how much? 3 by 2 I1. Now put the values each and every one. So let's solve it so that we can get the simplified result. So this will be how much? This will be 5 by 2 plus 10I1 minus 10 plus 10I1 plus 10I2, that is equal to 0, right? Now 5 by 2 plus 10I2, 15I2 and 20I1. So 20I1 plus 15I2 minus 10 is equal to 0. Minus 10 is equal to 0. Now put the values of I2. So this will be 20 I2 plus 15 into I2 means 3 by 2 I1 minus 10, that is equal to 0. So this is 20 I1, right? 85 I1 by 2 is equal to 10. I1 is equal to 10 by 85 into 2. So this will be how much? 4 by 17. So finally we have got I1 as a 4 by 17, and in this way you can also get I2. So just by using this one you can get all the values. Let's see here. Now let's so we have already got I1. Now let's find I2. I2 will be how much? So I2 will be equal to I2 is equal to 3 by 2 I1. So this will be how much? 6 by 17. Now we have got I1 as well as I2. Now just we need to find the current in each branch, right? So if you go through this one, so current through this branch, so if you put I, so I is equal to I1 plus I2, that is equal to 6 by 6, 6 by 17 plus 4 by 17, and this was probably it will be equal to 10 by 17. So this is the total current in this branch. So similarly in this also it will be 10 by 70. So it's a very easy method to solve it. Now this one I1 we have got, this current we have got, I2 also this current we have got. Now I1 minus I2 will be how much? I1 minus I2 will be how much? It will be minus 2 by 17, minus 2 by 17. It means that the current will get reversed, so our assumptions is wrong. So the direction of current will be this one. And I2 we have already done, I1 we have already done. I hope you have got this answer. Got it? Now let's go for solving next question. Yeah, this question is 3.8 and in 3.8 let's talk about what they have provided you. A storage battery of EMF is how much? 8 volt. And internal resistance is 0.5, is being charged by 120 volt DC supply. So let's talk it. There is a battery and there is also a external source which is supplying it, right? So there is a two batteries, right? One is charging and one got discharged, so due to which it will get charged, right? So what they have provided you, EMF. So EMF of the battery, storage battery, that is which is being charged, is how much? 8 volt. And internal resistance is 0.5 volt, 5 ohm, right? Now the voltage they have provided you 120, right? 120 volt. Got it? So resistance, external resistance is 15.5, right? Now the effective voltage, if you talk about the effective voltage, that is V dash, so this will be V minus E. Why B minus E? Because see, it's a one is charging and one is discharging. That's why. So we can write this. So this will be 120 volt and minus EMF is how much? 8. So this will be 112. So got it. So it is 112 volt. Now from this I, the current will be V dash by R capital plus this one, that is equal to 112 divided by capital R is 115.5 plus small r is how much? 5. So this will be how much? Small r is 0.5. So this will be 112 divided by 16. So finally we will get as 7 ampere, right? 7 ampere. Now voltage across supply will be how much? So voltage across supply will be how much? Voltage across supply will be current into resistance. So current is I into R is resistance. So current is I'm getting current as 7. Resistance, external resistance we have 15.5. So finally terminal voltage what we are talking about is how much? It will be 108.5, 108.5 volt, right? Now DC supply voltage, we know that DC supply is equal to terminal voltage plus voltage drop, terminal voltage plus voltage drop, right? So DC supply is equal to terminal voltage plus voltage supply. So from here terminal voltage, that is TV, will be how much? DC supply man, that is 1.120 minus voltage drop is how much? 108.5. So from here we can say that terminal voltage will be 11.5 volt. So I hope you have got this one, terminal voltage. Now the thing is that what they are telling, what is the purpose of having having a series resistors in the charging circuit? So what is the purpose of series resistor in charging circuit? Since it is in series, so it will limit the amount of current flow, right? It limit the amount of current flow, amount of current flow, right? Since it will limit the amount of current flow, so what will happen? The current will be extremely, if it is not available, so current will be extremely high. In its absence, current will be extremely high. So it may create a damage, right? So I hope you have understood this one. Now let's go for next question. Next question itself is saying that the number density of the free electron of a copper conductor is given by this one. How long does an electron take to drift? So they are asking time to drift from one end of the wire of a 3 meter long to the other end. If the area of cross section is given and the current is this one. So let's draw this condition. So there is a wire and it has a length of how much? 3 meter. And they are asking how much time will it take the electron from to reach from one end to another range. So if we know that drift velocity will be distance travel, that is equal to length divided by time t, and they have also provided you area, that is area of the cross section is equal to 2 into 10 to the power minus 6 meter square. Now we know that I is equal to NEA VD. Now VD itself is NEA. VD means length by time t, and this is current. Now what is N? N is the number of electrons per unit volume, that is equal to 3.1 into 10 to the power, sorry, it is not 3.1, it is equal to 8.5 into 10 to the power 28, right? So from here we can put the value so that we can get the time, right? So time will be equal to NEA L by I. So from here N is the number of electrons, that is we need to put 8.5 into 10 to the power 28 into electron charge. So E has a charge of 1.6 into 10 to the power minus 19 into area of cross section is given as 2 into 10 to the power minus 6 meter square. 2 into 10 to the power minus 6 into length is they have provided you 3 and divided by current they have provided you 3 ampere. So by using this we will get 2.7 into 10 to the power 4 second. So I hope you have enjoyed the session. Thank you for watching our video. Thank you everyone. Thank you.